Welcome to the Spacetime Diagram STD spreadsheet. When you first open it, it'll tell you that it has macros in it, and you need to enable those macros for this spreadsheet to work. In class, we'll talk about spacetime diagrams, and spacetime diagrams are simply position versus time graphs, except time is on the vertical axis and position is on the horizontal axis. And it's just how we tell the location in space and time of anything that happens. Okay? So this point right here is at x equals 3 and time ct equal to 3. Very boring, very plain. What we're interested in is objects that are traveling at high speed relative to this stationary, non-moving frame. And I can draw that reference frame in here. This is the world line of an object that is traveling at 4/10 of the speed of light. I can make it any speed I want by just typing in any speed that I'd like. Now, this is somebody in, say, a rocket ship moving at 0.6 the speed of light in the positive direction. How they measure time and how they measure distance is not the same as us. We can do calculations using the Lorentz transformations to figure all that out, and that's what this spreadsheet is trying to do without us doing the calculations. For instance, here are these grid lines. These grid lines are the same grid lines that we have and look rectangular to them, but because of the Lorentz transformation, they appear to be slanted to us. So if we look at this point here, x equals 4, ct equals 5, in their frame of reference, it's x slightly greater than 1, and it's 1, 2, 3, 3 and maybe a quarter in ct primed. We're going to show you an easier way of doing this, but this is just the grid lines for this moving frame. I'm going to turn those off and just point out we can move to the moving person's frame as well. And in the moving person's frame, if I look at the axis, it appears slanted. To any person moving relative to us, we're the ones who appear to have the funny numbers. Right? So we can use either of these graphs. Depends on how we want to use them. So I'm going to go back to my original frame. Now in this frame, I can change the scale however I want. Just type in the number and hit enter. The grid lines are a little close together, so I'm going to change the spacing here to 2 for both cases. It's a little more readable now. And this spacing on the x and the ct axis is always 2. But it's also the same here. This is 2 units in the moving frame. This is 2 units of time in the moving frame as well. So the spacing of the axes is identical. They don't look the same because of the Lorentz transformation. Now, we have these 2 frames, and we want to be able to make measurements. Sort of things we might want to do is draw some arrows. For instance, suppose somebody draws an object traveling at 0.4 of the speed of light relative to s. We've got this arrow that's just been drawn. Okay? I can move it around. If it's not long enough, or if it's too long, then all we do is go to the end, hold the Shift key and we can make it longer, shorter, or even turn it around. Okay. So we might ask, when does it get to this line, when x is equal to 10? Well, I can draw that guy easily enough as well, right? So move this over, x equals 10. And we can ask, when does it arrive? It arrives when the two arrows intersect. Now I can try reading them off the graph, but that's not the easiest thing to do. If I go back to the main menu, I can use find mouse coordinates to find any point on my graph. Let me move this over. And as you see, as I move my mouse around, the numbers change. And this tells me that I'm at x equals just under 10. Move it over a bit. Okay. It's going to be hard to get it exactly. It's at 10 and 25.39. And underneath, it's calculated in the moving frame as well. Right. So any points I want to find the location at, I can use this to find. So we're done with that. We're back to this graph setup. I should point out that I can clear anything I drew, or I can clear them all with these. Go back to that menu. And I should point out that when I use this find the mouse coordinates, it requires me to have actually made sure that I have the correct offsets for these points. I have them about right, but what I need to do is I have to make sure the first time I open any of these programs on a new machine is precisely where 0, 0 is. So I move to my frame, here's 0, 0. As close as possible, I try to make sure the mouse pointer is on 0, 0. It'll ask me, do you want to keep these values? Say yes. Go to the moving frame, and you're going to do the same thing. Okay. Yes. So you only need to find the offsets once for each of these charts on any machine that you do. The only time you would need to do it again is if somehow you change the shape of this graph, like that. That would change the offsets. Don't do that. Okay. If you close this graph, you can always get it back by hitting Control A. Sorry, that menu comes back if you hit Control A. Those are all the basic things you can do. So in your draw arrows, anything you want, you can draw many kinds of arrows. You can draw them more than once. Right? Okay. And you have all these arrows, virtually any kind of arrow that you need or straight line, and you can figure out whatever it is you need. Let's clear these all. Thank you. Bye for now.